So in this problem, we are provided with a value of sine theta plus cosine theta equals to 0 and the condition that theta is lying in the fourth quadrant. We're using that fact, we need to find out the value of sine theta and cosine theta. So let's begin. So we'll start with whatever we have been provided with. Here we are given sine theta plus cosine theta. So that's equals to 0, which means sine theta will be equals to negative times cosine theta. So let's label this as number 1. Now we know we have a standard identity which says that sine squared theta plus cosine squared theta has a value equals to 1. So what we can do, we have sine squared theta. In place of cosine squared theta, we can replace with negative sine theta whole square. So this is going to give us sine squared theta plus sine squared theta equals to 1. All we could have done is replace the value of sine squared theta with cosine squared theta. So this gives us 2 times sine squared theta equals to 1. Solving this, we're going to get sine squared theta, that's equals to half. Taking the square root on both sides, we get sine theta equals to plus or minus 1 over square root of 2. Now we're given that theta lies in the fourth quadrant. Now we know that if we have a quadrant system with 1, 2, 3, 4 as the fourth quadrant, all we have to do is remember the mnemonic A, S, T, C, and in the fourth quadrant we have C, which means the cosine and the secant function that are going to be positive, everything else is negative. Meaning sine theta is only can take a negative value, so sine theta is going to be negative 1 over square root of 2. So now that we have the value of sine theta, we can also obtain the value of cosine theta. So cosine theta, which is equals to negative of sine theta, that means cosine theta is going to be 1 over positive square root of 2. And it completely makes sense that cosine theta is a positive value because we are in the fourth quadrant where cosine is positive.